Okay, here we are. We're back to programming timers again. We're looking at this time the RTO, or the retentive timer. Let's go ahead and create some logic here. So we're in the main routine. I'm going to create a rung. Let's see here. I'm going to go ahead and grab a contact here. Go to timer counters. Under here is the RTO. Well, again, we're putting it in the wrong spot. Got to be an output command. I'm going to grab a binary bit here, sometime here, binary 0. Grab a timer address, timer 0 again. Automatically has already populated with 1000. So this is a two-part timer. It's going to need a reset for it. So I'm going to go ahead and incorporate that as well. We've got a RES we got to include into here. So I'm going to grab this piece here, go back to timer. You're going to see this RES. Again, putting it at the input. I don't understand this. Alan Bradley's software sometimes. It makes me crazy. Why would you want an output at an input? It's totally beyond me. So this is really easy. So this is here. We're just going to grab a binary here. So we're going to have binary 0 to initiate the timer, and a binary 1 to reset the timer. I'm going to come in here. So this timer 0 has got to be the same address. All I do is grab it and drop it right in. So as you can see, this number has, or this address has to be exactly the same as this. So by dragging it over makes it impossible to screw it up. So now you've got the RTO, the retentive timer, and we've got the reset. To watch this operate, I'm going to go ahead and download this real quick. Here we are, downloaded. You can see we're downloaded in run mode and all that business because we got these green rungs. They're highlighted on both sides. This is something else to keep in mind, excuse me. When you're in run mode and everything is operational and all is good, you will see these things highlighted here on both sides, indicating that, the logic is truly being solved. Okay. So next piece of this, I'm going to go ahead and I'm going to toggle this guy on. I'm going to Control T it. Control T is toggle on. As you can see here, it works just like the timer on. As soon as I close this, the enable bit turns on. After 1 second, the done bit turns on. So now it's enabled and the done bit are on. And if I toggle it off, I'm going to hit Control T again. The difference is the enable drops out, but what, the done bit stays on. Accumulated value does not reset to 0 when the input is turned off. When I come down to here and toggle this reset, I'm going to toggle him, Control T him. As you see, at that very moment, the accumulated value goes to 0 and the done bit turns off. Now, I am aware that the reset does work on timer ons and timer offs as well, but it's not used for those applications. So if you develop code using a reset of a timer, that like a timer on or a timer off, that's not going to be accepted. So make sure you understand a timer on, a timer off, and a retentive timer. So the reset is only to be used with the retentive timer. So keep that in mind. So next, we're going to piece of this. I'm going to go ahead and I'm going to create rungs of logic to illustrate how the done bit and all those bits are utilized. So let's grab that information and an output. And for whatever reason, it's not liking this business here. I don't understand it. This is timer 0. Enable. And I've got bit 0, bit 1, so now I got to use binary 2, right? I can't if I use binary 0 or 2, 1 here, every time this went on, it reset the timer. Every time this enable turned on, it would mess with this bit here. So this would tie to this. We don't want that. We want to make sure we're using individual bits for each one of these pieces. So now I'm going to duplicate this rung. Paste. I can use Control V and Control C and Control V, or however I want to do it for cut and paste. So that's always options as well. I'm going to grab this for TNT, and this is going to be the done bit. So I got timer EN, TT, DN, binary 2, binary 3, and binary 4. Let's go ahead and download this information and see what we end up with. Okay, so now we have this program in place. It's downloaded, so all I have to do now is toggle this by Control T here, and you will see the EN turn on, the TT turn on immediately, and the done bit turn on. So now, as you can see, with that input still on, the enable and the done bit are on. So as soon as I toggle this guy off, Control T again, toggle off, it is at that very moment that we have just the done bit on. Now if I come over here and toggle this guy, you will see the done bit turn off. And the accumulated value go back to 0. Like we have in the past, we're going to take a look at those controller tags, compare how those work. So let's first set this to 5,000 so we can watch this take place at as a slower rate. So I got to turn, that's a good point. If I do not turn this reset off and I click this guy, watch what's going to happen here. What happens? See, the enable doesn't turn on, the done bit doesn't turn on. Because why? The reset is being enabled. If that reset is on, that timer is not going to do anything, okay? This is one of those gotcha moments. So if you are using the retentive timer, you got to make sure that that reset is not enabled anymore. So as soon as I toggle this guy off, Control T this guy, look at what it does. It starts timing immediately. So that reset has a lot of power over that timer. So keep that in mind. So now we're, as you can see, that you can watch the 5,000 take place. You could see the enable turn on. The timer timing was on, and then the done bit turned on, and the timer timing turned off. We're looking at controller tags. They all operate the same way, and if you looked at the binary, we can start with that, I guess, because I've got this up first. Here is the binary, and ladder program here. As you can see here, the binaries I have. Binary 0 is on, binary 1 is off, binary 2 is on, binary 3 is off, binary 4 is on, represented by 1s and 0s in the data table. So keep this in mind. This is how easy way to troubleshoot things, okay? Another piece of this is we're looking at the timer itself. We go to controller tags, we go into the timer 0. We can grab that information as well. Go back over to main routine and pop this guy back up again. So now we're looking at the timer itself. We have a preset value of 5,000, excuse me, accumulated value of 5,000, as you can see here. The enable bit is on, as you can see here. The timer timing is off as a 0, and done is on, so as a 1. Okay, so now we know that we can see everything that we need to see for the PLC in the data table. What my objective behind bringing up the data table each time is to get you guys more familiar with using the data table, because why? It's a big piece of the puzzle. It is the background. It's where all that information is utilized by the PLC. The PLC scans the code, of course. It updates all these bits in your ladder program, but what it's really doing is it's taking this information and turning on 1s and 0s in this area here. So it recognizes this data table as its playground, as that is the area where it actually utilizes all those 1s and 0s to make decisions. So so keep that in mind. That is the base of it all. So that is retentive timers. So one nice thing with retentive timers is that, that we can do something as simple as if we go here, we Control T that. I'll Control T this. Turn it back off again. But I can come in here and I can go Control T and Control T again, and that maintains that information. It retains it. It holds it at 1515, for instance, in this particular case. That's how long I held it. I held it for 1.515 seconds is how long I held that on. So, and then if I come back in here and hit T again and remove it, now this timer has actually been on now for 2.179 seconds. So it gives you the ability to monitor time with like breaks in there, so we can get so if we need a total accumulated time of 5,000, for instance, we will have that ability to do that very thing. So we'll look at the total accumulated time with breaks in there. So that's the big selling point for that. And then at any time, we don't have to reach the done bit to attain that value. We can come in here and Control T it and reset it to 0 at any time. So that's kind of a nice feature. One point that I would like to share is, yes, you can use the done bit here. Just this, let's see here. Let's go. Let's do some online editing. So if I want to online edit this thing, I'm just going to come over here to the left. I'm going to click on it. You see the eyes. This is the rung that's going to be edited, and it duplicates it and says this is the original logic here. So I'm going to come in here. I'm going to grab the done and put that here. Come over here and accept this rung. So now I've got the done bit hitting the reset. How do you suppose this is going to work? It's going to reach the value of 5,000 and then reset it back to 0. Kind of an interesting way of doing things. So we can do that. Let's take a look at that real quick. So I hit this guy here. Notice that reset overrides everything. See, I even left this on, and with that reset on, it goes right back to 0. So it doesn't matter. It's going to continue to count to 5,000 and then reset to 0. One of the points I'd like to share is that that done takes place so fast that our screen can't update fast enough to acknowledge it, so you don't really see it. All you see is it switched back to a lower value, sometimes not even to 0, because why? It's already been on for longer than that by time which it updates the screen. So, so this is about as close to real time as you can get. So that's just another piece of that puzzle to make you aware of how it works. Okay. So that is retentive timers. All right. We'll catch up with you later. Talk to you. Bye.